So before we start, and before I introduce the panelists, may I start by a brief introduction and say that obviously the nuclear industry appears to be firmly back on in terms of agenda after a period of significant contraction brought about by the Fukushima disaster in 2011. But now obviously it is becoming or looking like an increasingly attractive option for companies and countries to begin to start looking at the development of the sector once again, basically driven by a lot of new technology and new promises in terms of what the cost of nuclear might be, both in terms of both in terms of project development and indeed operational costs, which we shall discuss in detail as we go through this. Clearly, SMRs, small modular reactors, plays a key role in this, but also we will be looking at other nuclear technologies, particularly the maritime sector, during the discussion, which I think will be of interest, particularly here in Singapore, in addition to the nuclear sector's possibilities within the power sector. There are lots of questions around how nuclear will develop within the context of the net zero agenda going forwards. There are lots of issues that still need to be resolved in terms of regulatory issues, in terms of safety concerns and socialization of nuclear, all of which we hope to discuss today. So without further ado, it gives me great pleasure to introduce our first speaker today, Paul. And Paul is from Rolls-Royce and is a chartered engineer and a fellow at the Institute of Engineering and Technology and Institute of Mechanical Engineers. And Paul has been involved in SMRs for quite some time now, and will actually start our conversation today talking specifically about Rolls-Royce and where the SMR design program is moving to, both in the UK and some of their aspirations in terms of building out their business globally. So Paul, if I can ask you to put on your camera, put on your microphone, and over to you, sir.
Okay, yeah, thanks, Peter. Thanks for the introduction and inviting me along this afternoon. So as you say, I'm head of engineering at Rolls-Royce. I've been with the SMR program for around about 2.5 years now, working largely in the manufacturing arena, and now I've moved across to what is a similar job but broader, to pick up as head of engineering. So that's a little bit about me. But again, for today, thanks again for inviting me along and for, I think, posing a really great question: can nuclear contribute to carbon net zero? Well, I think the simple answer is yes, it can, and I'll try and explain why I believe Rolls-Royce SMR can make this happen. So what I'll do is introduce the Rolls-Royce SMR business. We're a new business, so I'll take you through a little bit of that. I'll look at the market we're targeting. I'll outline our product, and I'll consider the future and what the future could look like. And there's a bit of an economic theme running throughout that. Before I launch into that, you probably see from the sketch on the screen here, Rolls-Royce SMR is not simply a nuclear reactor design, it's a civil nuclear power station. And that's a really important message to get across, and I'll pick up on that as we work through. So this is Rolls-Royce SMR. We're not starting afresh. Our team in SMR is a fantastic heritage. Rolls-Royce has a long association with the design and manufacture and operation of nuclear power plant. And we've drawn on that heritage and embedded it within SMR, so it really makes us match fit. And that's important given the growing interest, as you've already touched on, Peter, the growing interest to get product to market. So that's great. So we launched as Rolls-Royce SMR Limited in November last year. But that was really the culmination of a huge amount of effort, and I've already touched on that. We started really to look at SMR in seriousness around about 2015. And before that, Rolls-Royce had actually done some work in the early 1980s looking at SMR. So although we're a new business, Rolls-Royce's ambition for SMR started some time ago, and we built on that. But the other people on the screen are important. So Rolls-Royce is joined by others who've got really similar ambitions. So we got BNF Resources, we've got the Qatar Investment Authority, and we've got Constellation Energy. So they're the 4 shareholders that form up the business, and these, together with UK government grant funding, enable that $660 million program that we're now into. So circa £500 million UK, and that takes us through to the end of the regulatory process and the final concept design. So it's not the whole amount, but it's a big chunk of it, and that's what we're currently working on. Before I move on, it's probably worth saying a little bit about Constellation. If you're not aware, they're a US utility. They're the #1 generator of carbon-free energy in the US. They're the largest commercial operator of nuclear assets globally, and they achieve some of the highest operational performance standards in the nuclear industry. So Constellation bring a really rich depth of operational knowledge and understanding, and really complement the Rolls-Royce capabilities that we've got in the team. So I think that shared blend of experience really differentiates Rolls-Royce SMR from other organisations and similar developers of reactor, small reactor systems. It's something we're really, really proud of and intend to build on. Again, reinforcing, I think it's a really great time to be talking about nuclear, and a completely new way of delivering clean energy using our Rolls-Royce SMR. I think whichever way you look at future predictions of energy consumption, under all scenarios, fundamentally we're going to need more electricity, either on grid or off grid, and I'll touch on that later. That growing demand to reduce emitters, and the fact many nuclear stations are either reaching the end of their life or are already decommissioned, means that that demand for new sources of electricity that's clean and low cost and importantly dependable will become increasingly prominent over the next years ahead. And we certainly believe our SMR is a product that can address these needs and provide a means to help establish and maintain a high quality, clean and affordable energy solution, and I'll walk you through that. So what are we doing in SMR? Why are we different? Why are we taking a different approach? When we kicked off in 2015, we looked at the market, and it was clear very quickly that really all the utilities want safe, low cost, clean energy that can produce and sold at a profit. That's largely dictated by the levelized cost of electricity equation. So consequently, we recognised that we needed to control all elements within this equation, basically trying to minimise everything on the top and maximising everything on the bottom of the quotient. And then around that, all the peripheral dependencies and drivers that sit out with this equation, the kind of thing that like the regulatory aspects, the market, the public perception, the infrastructure and so on. We simply categorise that as external risks and opportunities that we need to understand and we need to manage. And that's the way we started to tackle it. We also did a deep dive on other civil SMR programs and found that primarily their focus looks at the reactor, the fuel cycle and control systems, with very little effort on other things. But conversely, when we took a look at the critical risks that civil power station programs normally encounter, it kind of related to the other things. In particular, risks associated with civil engineering, with the manufacturing supply chain, and really not much done around the digital technologies and how that digital ecosystem can massively help drive out cost and improve productivity. So we concluded that these other things are really where Rolls-Royce SMR needs to take its attention and focus its efforts and innovation and funding. So fundamentally, our approach is different because our goal is to bring a product swiftly to market that meets customer needs, it's safe and it's commercially viable. It's affordable, it must be cost competitive. It's deliverable, it must be deployable with confidence at pace. And to do that, we need to avoid complexity and associated build risks. It needs to be scalable, so we can manufacture it and we can build a global fleet of stations and maximise the standardisation efficiencies that we can drive in. And really, really importantly, it needs to be investable. It needs to be able to attract private capital that's not tethered to these large multi-billion-dollar loans that we typically see in civil nuclear. So the cost of borrowing is minimised, and there's a swift return on investment. If I take a very simplistic engineer's view of life, if I take an engineer's perspective, this largely equates to delivering to cost, to quality, and on time. So basic stuff from my perspective there. So we took all those needs and opportunities and drivers, and this is the specification we've arrived at. Rolls-Royce SMR is a 470 megawatt electric, fully integrated nuclear power station. At its heart, we're using a well-proven nuclear technology. It's a generation 3 plus pressurized water reactor design, and we're using conventional low enriched fuel. That simplifies that whole supply chain and the regulatory process. And this configuration is something Rolls-Royce understands, and we know how to design and we know how to build it. And that's really important in terms of keeping costs low. I think furthermore, if we take that 470 megawatts, what that means is the secondary systems, the balance of plant, becomes something that's easily sourced. And we can go by that today. There's already commercially available solutions there for multiple suppliers, and those discussions are very much in an advanced state. So that cost, quality, and on-time delivery is then achieved by using modularization, standardization, and modern high-performance manufacturing methods and techniques. And by driving as much of that into a factory environment, I'll come on to that later. But taking it into a factory environment, that's where you can really maximize productivity and de-risk traditional delivery constraints. So the other key thing I touched on, our product needs to be scalable. It is, because we do it in all that way, and it must meet customer demand, irrespective of where the factories are located, and we've got a solution for that. And as you can see there from the slide, we could do quite a lot with our SMR. Yeah, we can do the domestic stuff, we can put stuff on grid, but equally we can start to look at sustainable fuels and other things. And I say I'll touch on that later. I'll unpick more of this on the remaining few slides. So what's it look like? Bit of an overview of the power station. The primary reactor plant sits within that containment vessel located within the reactor island. To give it a bit of scale, the containment vessel is about 40 meters high, it's about 30 meters diameter. And that's where the nuclear reactor sits, and that's where the hot water is generated, and we use that to make steam. Steam then passes to high and low pressure turbines in this turbine island, and that's where we generate electricity. And then any residual stream we condense and send it back to the steam generator feed system. So we conserve water in that way. And then the cooling water island, that's used to manage the heat balance across the plant. As you would expect, there's a whole load of other systems around the patch that look at functional and safety aspects, and to ensure that the operating range of the plant keeps under control so that we're efficient and we're safe. I think another important aspect of characterization is that we use modular cooling towers to give maximum flexibility for site locations. So we don't need to be part or next to the sea. We don't need to be near a big river. Clearly do need water, but by using cooling towers, we don't discharge surplus hot water into the sea or rivers, so we protect the ecosystem in that way. Also, that hot water we can repurpose, and we could use it for other applications such as domestic heating or agricultural heating needs. So we're trying to consider that as part of the design. I've talked about standardization already, but as you would expect, not all power stations are located with the same geology and seismic withstand risks. So we deal with that using an aseismic bearing. So we tune that as aseismic bearing to the individual site conditions. What that means is that we put the bearing down to suit the site, and then everything above it we can standardize. Everything above it is identical across the whole fleet, and again, that's about driving cost out and delivery performance in. Another important aspect you can see here is that perimeter berm. It's really important, that dominant earthwork around the station. You can see that provides resilience against external threats such as natural disasters or infiltration or terrorism. And similarly, the facets on the roof shroud are designed to deflect and disrupt missiles and debris that could accidentally impact the site. So you start to see safety, engineering and economics drive everything we do. But nevertheless, we've looked with the architects how to create a power station that's deliberately iconic and sympathetic with the landscape. And all that combines to reinforce that Rolls-Royce SMR is a new approach to delivering nuclear power. It's affordable, but it looks good as well. It's sympathetic with the environment. Bit on the manufacturing piece, really important. Our commoditized design approach for manufacturing is economic because, as I've already mentioned, we aim to build a fleet of stations in the UK and globally. And that's really an important piece of the jigsaw that makes our factory-built power station repeatable and cost-effective. We manufacture in a controlled factory environment off-site using advanced flow lines, quality and testing regimes. We use industrial digital technologies, and we then install and commission these high value commodities in a controlled environment at site, in a weatherproof site factory. That whole process is coordinated and verified using a digital twin that brings together a controlled digital record of the configuration of the power station, and that's used not just for the build and manufacturing operations, but that digital twin then carries on with the power station through life. It's a really important way of ensuring the things working as we expect, and we've got the right things like maintenance regimes and that kind of thing. Again, building in efficiencies as we go through life. So what we're trying to do here is bring very much a Rolls-Royce approach to making quality products. We're bringing that approach to a 21st century civil nuclear power station, and that's a paradigm shift from the traditional civil nuclear approach. So all this, together with how managed the site work, is our unique selling point, and it's what makes the end-to-end economics all add up. Before I move on, it's worth saying a bit more about the site factory. I think a concern with any civil construction site is the local impact on the environment, things like the dust, the light, the noise, and so on. And the other key element is weather, and that can really hinder progress due to wind and rain and ice and other outages. The program costs for these kind of outages are massive, and if you just take a UK sort of location, that can easily add up to hundreds and hundreds of lost days to the program. So we thought about that, and we've used a solution that draws on our experience of building and maintaining submarines. Basically, we create a temporary structure and we run it as an enclosed, fully serviced factory. So all round much better for staff, staff welfare, health and safety, quality, and the environment. So we're really trying to control that whole approach to how we put this thing together. I guess just to labour the point, as I've said, we're not simply a nuclear reactor designer that's trying to sell a reactor concept. What we're doing at Rolls-Royce SMR is delivering a fully integrated turnkey nuclear power station, and we do that under a single contract. We provide the component designs, the system engineering, the plant integration. We manage the logistics and the supply chain. As I already said, we build in factories, we transport to site, we assemble it at site, we start it up and we commission it, and then we hand it over to the customer. So it's a full turnkey solution. And then the customer operates it over its lifetime for what's needed, whether it's on-grid or off-grid power. But in my new job, I've got a big element of ensuring we've got engineering talent. So I have no apologies here, but I'll do a bit of plug for Rolls-Royce SMR. It's not just about clean and affordable energy. The programme also creates a wealth of job and career opportunities for all the communities we operate within. So if there's anybody is interested and keen to come and join us at SMR, come and have a chat. And please go and have a look at their website. So apologies for the plug, but I had to get it in there. And then just a few closing slides. I think our SMR is too elegant a solution to simply use for base load on-grid power. That's often trotted out as the purpose of nuclear. I think we can be cleverer than that. And I think it's important to take a much wider look at potential opportunities. And there's a few sensible ones on this slide here, a few sensible and practical industrial applications and ideas. We very much see our SMR as a product that can sit within this global industrial arena. And I think it's important we start to look at it that kind of way. We look at nuclear that way. Just a quick one on timeline. This is the current timeline that we're working within. Final concept design completes middle of next year. We expect UK regulatory approval to complete Q3 2026. We're already into that approval process. We started discussions with the regulator as part of the phase of the programme a few weeks ago. So that's already in hand, already going well. And we're driving very hard to be on grid by the end of the decade. And there's some people trying to bring us even further left than that, but we'll see. We'll see what we can do. And then final slide. I think great strides are underway to increase wind and solar, and clearly that must continue. We're a big advocate for that, but there are shortfalls, and I'm sure others will have discussed that later, and there's probably a few questions around that, so I'll not dwell on that. But I think either way, affordable and investable, always on low carbon power is needed, and this can be backed by RollsRoyce SMR. So I think I'll stop there, Peter, if that's okay. I'll just leave you with this vision of what the future could look like, and yeah, welcome the discussion later on. Thanks very much.
Many thanks, Paul. That was a great presentation. And as you say, it's probably raised a lot of questions. So may I remind the audience that we will be taking Q&A. So do please put Q&A down. I mean, clearly a lot of questions around pace and scale of development and how the market is going to accept SMRs going forwards, both in Europe and the UK, where obviously things are beginning to start kicking off, but also from an international perspective. So we'll come back and talk about that later on, I'm sure, Paul. So thank you very much.
Okay, thank you.
So, what I'd like to do now is introduce our second speaker, Clare Turgoose, who will further expand on Paul's comments, I'm sure. Clare is actually an analyst at Sizewell C Project in the UK, where her role specifically relates to making the case for new nuclear in the UK and engaging with the government and investors to develop it, the financing and business frameworks for the Sizewell C Project. So we couldn't really ask for someone better to follow Paul in terms of taking some of the story of Rolls-Royce and what they're trying to develop and put it into the perspective of where markets are going to go, and certainly where the UK is likely to go in terms of the nuclear sector going forwards. Clare is also a member of the Nuclear Institute Young Generation Network Committee and is a very active member of the Nuclear Institute. So welcome, Clare. We're looking forward to hearing what you have to say. So over to you. Thank you.
Thanks, Peter. So hi, everyone. As Peter said, I currently work on the Sizewell C Project. I've been doing this role now for about 2.5 years, and prior to that, I worked within the energy industry. So I'm a strong advocate for nuclear power and the role that it can play in helping us tackle climate change and supporting the UK and countries around the world in getting to net zero and phasing out fossil fuels. As part of my role on the committee for the Nuclear Institute Young Generation Network, I do a lot of work looking at how we can advocate and communicate externally as an industry about the benefits of nuclear power and the technology. This is something that perhaps historically the industry hasn't been as good at doing. We're very good at talking internally and talking to ourselves, but not as good at doing that external facing role where we're promoting the technologies. And so that's something that I've done a lot within the Young Generation Network, and we're really starting to see a change in the narrative and the perception of nuclear, particularly within the UK and with recent government announcements around the energy strategy, which are starting to put nuclear very much at the centre alongside renewables, and seeing these technologies as working together in order to get to net zero. So I thought I would talk to you today a little bit about the case for nuclear initially, and then, as Peter mentioned, my main role is within the Sizewell C Project. So I'll give an overview of where we are with that project. It's a really key year for us at Sizewell. And then I'll touch on the end a little bit about the proposed financing model for Sizewell C and for new nuclear within the UK. So in terms of the case for nuclear, we know that energy security is very high on the agenda at the moment across Europe and across the world. And so it's a really important time to discuss opportunities to invest in clean infrastructure, such as new nuclear power plants. Within the UK, we have a target to achieve net zero by 2050. And these sorts of targets are really being seen across countries in all parts of the world. And so there's this really big push to phase out fossil fuels, but maintain a supply, an energy mix that is secure and that doesn't put unnecessarily high costs on the consumer. So it's balancing all of these things as we transition to net zero. That's the key challenge for governments, but also industry. So nuclear power is a proven technology. It provides zero carbon, non-weather dependent electricity. And in the current geopolitical climate, it also has the benefit of being a technology that a country can have a high level of control and security over as well. So within the UK, the context is that around 20% of our power comes from nuclear at the moment and has done for decades. However, around the majority of that nuclear power is going to come off grid in the next decade, so by the 2030s. That's with the exception of Sizewell B, and then Hinkley Point C, which is a twin project to Sizewell, which is currently under construction in Somerset. So that poses a really big gap or sort of challenge for the UK as we're looking to transition to net zero, because not only do we know we're going to need to replace the fossil fuels on the system, we also know that our demand for energy will increase as we look to electrify other sectors such as transport and industry. And so there's an even bigger need for power. But we also know that our existing nuclear fleet is largely going to come offline. So there's a really big drive to build more of all forms of low carbon power and to do this as quickly as possible in order to meet our targets and maintain a secure supply. So the UK government very much recognises the role that nuclear can play in this. A couple of the commitments that we've seen. So last year, the government committed to bringing at least one more gigawatt scale nuclear power plant to final investment decision by the end of this parliament, subject to value for money and ensuring that it's at a fair cost to the consumer. So that is one commitment as a follow-on from Hinkley Point C that we've seen from the government. And in the energy security strategy, which came out a couple of weeks ago, we also saw, as I mentioned, nuclear being very much central to the government's plans to deliver net zero alongside offshore wind and many other forms of low carbon technology. So that's great, and it's a real development of the narrative that we've seen from government over the last few years. I think certainly when I initially joined the project and joined the industry, the focus on nuclear was far less. So actually seeing this strategy from the government recently, which puts nuclear at the centre, is really fantastic and really great for the industry and our net zero commitments within the UK. So that's the context, a bit quite UK focused, but gives an overall feel for the case for nuclear as well, I hope. So I'll talk a little bit about Sizewell now. So as I mentioned, I've been an analyst in the team for the last couple of years. I am within the financing and economic regulation team, which is a little bit of a mouthful, but essentially it's the team that initially was making the case for the project to government and to investors, and is now having conversations with these different parties to support the development of the financing framework for Sizewell. And so it's a big year for us on the project. We have submitted our development consent order and our full planning application, and that was following around 8 years of consultation with local stakeholders, with the community. That is now with the Secretary of State within the UK to review, and so our planning team are quite busy responding to some of the questions that are coming from the Secretary of State and from the government about that planning application, but we think this should be a final push. And we're expecting a decision and the grant of the development consent order around the middle of this year. Alongside that planning work, we are also engaging with the investment community and looking to make the case for nuclear as a green investment opportunity within the industry and within the finance community. And we're having really positive conversations with them at the sort of broader level of the case for nuclear, but also in the detail of the financing model, and working with government and investors to develop this in a way that works for all of the different parties involved. So that leads me on really to the financing model for Sizewell C. And this month we heard really great news that the legislation for a regulated asset-based financing model for new nuclear in the UK has now been passed into law. So the regulated asset-based financing model is the model that we're proposing to use at Sizewell C. And essentially it will provide returns to investors throughout the construction period of the nuclear power plant. And as we know, for nuclear, that's a relatively long construction period. It's around 10 to 12 years for Hinkley and Sizewell. And so receiving those returns throughout construction provides investors with greater certainty, and it lowers the cost of capital. And so lowering the cost of capital, therefore, reduces the overall cost to the consumer. And so this investment model, having passed through Parliament with, I should say, it had really strong cross-party support from Conservatives and Labour. And then it also went to the House of Lords. This is the process for passing legislation in the UK, with very minimal amendments to then become law in quite a short period of time as these bills go. And so we would look to attract private finance to the Sizewell C project via the regulated asset-based model. The regulated asset-based model is new for new nuclear, but isn't a new model. And so in the UK, it's something that has been used to finance around 180 billion of UK infrastructure already. That's things like the networks are financed under a RAB model, and also Thames Tideway Tunnel, which is a project in London in the UK. So not a new financing model, but a new way to finance nuclear. And Sizewell C particularly is able to access this as a second of a kind project, replicating Hinkley Point C and having that greater certainty and reduced risk around the project itself. So that's a bit of an overview really of the case for nuclear, Sizewell C and where we are, and the proposed financing model and where we are with that. So I'm very happy to take any questions at the end, and look forward to hearing from our other speakers.
Claire, thanks very much. Just before going on to Mikal, let me just come back to this regulated asset-based model, because here I am sitting in Singapore, and obviously we have a regional audience here that are beginning to start looking at nuclear, but wondering, for God's sake, how we go about financing that, given the fact that obviously we have no regulations or anything in place yet. The regulated asset-based model could prove to be the foundation of something in this part of the world as well. So given the fact that it's at the early stage of development in the UK, obviously the Europeans are looking at something similar, and now that will probably be accelerated because of the geopolitical crisis around Ukraine and Russia, of course. Where do you think this regulated asset-based model will go? Do you think it's going to become part of a standardized structure going forwards that other governments and other jurisdictions will take onto themselves to develop in a similar way?
I think it's certainly something that other governments can look at and see how the UK is financing new nuclear. The regulated asset-based model is very much a proven model for financing infrastructure. So like I said, it's been used for a number of different projects across the UK. For the nuclear industry, Sizewell C as a project is the first opportunity to build a second of a kind gigawatt scale nuclear project in the UK. So Hinkley Point C was the first of a kind, and Sizewell C will be a near identical replica. And it's through this replication and the reduction of risk that we're able to access and make a regulated asset-based model attractive to the private investment community. The investment community that we're going out to is not only in the UK, it is institutional investors from around the world. So certainly if through this UK project, we're able to attract this investment from these different investors, then that sets a precedent for them in terms of getting comfortable with investing in new nuclear via this model. And so it's something that they may well be interested in doing for other countries.
Okay, thank you. And I'm sure we'll get back to that. And without further ado, I'm sure Mikhail is going to talk about it next. So let me introduce Mikhail. Mikhail Bo, I've known for some years, and some of you might know him if you've been in Singapore. I mean, Mikhail was based here working in the maritime sector. He's now in London, but actually Mikhail is originally a Norwegian by birth, and has a lot of experience in shipping and finance and technology. And is the chairman and CEO of a company called Core Power, which is very much focused on looking at nuclear from a very different angle around the maritime sector, and where obviously the nuclear sector can be developed even beyond SMRs and the technologies that may be introduced accordingly. So without further ado, Mikal, I'm sure you're going to pick up from Claire and her comments about the RAB model and how that may also play into where you see industry development from a maritime sector point of view. Over to you, sir.
Thank you very much, Peter. I'm going to have another go at sharing this screen and see if we can get that up and running before we do this. So,
I did see the slide before, so yep, that's it.
That's up and running, is it?
Up and running. Just need to go to slideshow.
Excellent. Very good. Look, thank you very much, Peter, and thank you both to Paul and Claire for excellent presentations so far. It's a pleasure to be speaking here this morning in London, afternoon in Singapore. I'm going to spend the next 20 minutes just taking this a little step further. And the first thing I'd like to say is that I think what we have really under the banner of this webinar, answering the question, can nuclear contribute to net zero? Well, I actually think the answer is, or rather, the question could be asked differently. What else can contribute to net zero? We have an immense need for resilient power. I mean, if we don't have resilience, if we don't have the durability of electric power, not just for homes and for heating and cooling, but also for industry and for critical infrastructure, then we can't move away from fossil fuels. That's the long and short of it. Intermittent power, however much we think solar and wind and geothermal, etc., is going to be providing energy in the future, we have to have resilient and durable power that we can rely on. We can't have blackouts in advanced communities. So as a result, I think what we need to do is we need to think about nuclear really as a broader thing than what it has been so far. Conventional nuclear, as we know it today, was started in the 1940s, developed as commercial power stations in the 1950s. Most of what we have today was built in the 70s and 80s. Don't forget, Fukushima was completed in 1971. It's quite an old system. And still what we're building today is the conventional nuclear reactor technologies that we've had for so long. They're very good. They function beautifully. I think Paul demonstrates what Rolls-Royce can do with that technology in a modern setting, and it's absolutely fantastic. But what we really need is technological diversity so that we can use nuclear for more than just grid power. As Paul said, we can do things with hydrogen production. We can do things with water desalination. We can power small areas with this. We believe, however, that there is a really good combination in advanced nuclear technologies, new technologies that are different from the types that we see today, combined with the maritime space. And the reason why we think the maritime space and the maritime industries are particularly interesting for nuclear is because it is really nuclearism is an industry that's looking for a way to become a mass market technology. And in order to do so, it needs to go from being a project to being a product. And the shipping industry and the maritime industry has, if you like, the ultimate manufacturing facility, the ultimate sort of manufacturing capability in doing so through shipyards. Shipyards are probably the most efficient way to construct, repeat versions of complex machinery and fast turnaround times and economic price. And we believe that if we can combine new reactor technologies with maritime assets, we can have a situation where we can construct somewhere and deploy somewhere else without having to stand up a new project everywhere this needs to be done. Now, this is again part of the technological diversity that we'd like to see happening, and not a replacement of conventional nuclear technology that's being deployed in large power stations, etc. In order for the maritime industry really to embrace nuclear and for nuclear to use the maritime industry as a vehicle forward, we have to meet three key criteria. One is we have to be able to create long fuel cycles. This idea that we need to refuel conventional reactors every, say, 18 months, 24 months, every couple of years, basically, means that we have no further real movement in the issue of one of the most unpopular things that we have, which is nuclear waste. Now, nuclear waste isn't really a problem. It's perceived as being a problem, but we have to move into an era where we're running much longer fuel cycles than what we are today. We're looking at anything between 10 and 20 years, potentially up to 30 years, depending on the different type of applications that are used here. That solves an awful lot of issues around non-proliferation.
Mikhail, can I just disturb you for a minute? You're still on your introductory slide. Are you meant to be moving on?
I am. Why isn't it moving on? Okay, so if I do...
You're maybe not on your slideshow. There we go. Thank you. Okay,
so yeah, okay, apologies. So these three criteria is long fuel cycles. The second one, which I think is probably the most important one, is that we need to be able to operate with machines that have no pressure and or only ambient pressure. And this enables us to move to what's essentially very small emergency planning zones. I'll get back to that later on. But it means that we can put nuclear technologies close to people, in ports, close to coastlines, etc., without having large emergency planning zones around them. And that idea that we can build them in shipyards through modular design and construction means that we can make them affordable and a mass assembled product. So rather than a project, it becomes a product. And I think that's those are some of the key issues that we have here. Just check, Peter, did that move on to the next slide?
Yes, that's fine.
Very good. Okay. So in terms of maritime applications, there are several interesting target markets that we can look at then. So we're really looking at everything from nuclear electric propulsion of ships, which isn't necessarily going to work for all types of ships, but it's going to work for some of the largest ships out there. Don't forget, in the shipping industry, we've got about 20% of the ships out of a fleet of 100,000 ships, so about 20,000 out of 100,000 ships, consuming about 80% of all marine fuels. So basically providing 80% of all the pollution. So a small number of ships solves the pollution issue from shipping. So nuclear electric propulsion is a very interesting market, which we're getting a lot of support from. The other one, of course, is floating power stations. This idea that you can have power barges, you can have spars, like the one that's shown a picture there. It's basically a floating power station of 1.2 gigawatt electric that can be constructed in a shipyard and moved into position where it's needed. And this would be in the territorial waters of advanced nations with solid nuclear regulators and maritime regulators. The United States, United Kingdom, France, etc., could have these, potentially Singapore as well, could have these, in their waters, being really a power station that's immune to tsunamis, to storm surges, to hurricanes and cyclones, etc. And again, with no pressure on board, requiring a very small emergency planning zone around it. We believe this is something that we can provide anything from about 5 to 10 megawatts for small countries like Tonga, up to several gigawatts for large nations that require enormous amounts of power. So coastal communities is really where this fits in. Island states in the Pacific, Mediterranean, Caribbean, again, we can provide that kind of small, compact, floating power solution for grid, for water desalination, and potentially also for some localized hydrogen production that's completely resilient to the environment. floating data centers, mini-grid infrastructure, and of course light industry are also potential solutions for this. We're working on several designs with some of the big vendors out there. One of the most exciting ones that we're involved in at the moment is a molten salt reactor. In particular, this is a molten chloride fast reactor. It's the first ever fast spectrum molten salt reactor that's been built, and we've got a program now running with an organization in the United States called TerraPower. Southern Company, one of the big utilities in the United States, Orano, the French national nuclear fuels company, and of course with backing from the US government, from the US Department of Energy, where this is now being built at Idaho National Laboratory. The first of the small test reactors will be finished in 2025. That's really an experimental reactor to prove the neutronics of this. And then we're expecting demonstration programs to start then post 2026. The nice thing about the molten chloride fast reactor is that it does things differently. It's a liquid fueled reactor, it has ambient pressure only, and it has an exceptional fuel efficiency. This idea that we can run a very long fuel cycle with a liquid fuel circulating naturally around the reactor means that we're effectively running a fuel efficiency equivalent to consuming 1 gram of fuel per megawatt day, which leaves the tiniest little waste footprint that you can imagine. So this is really new types of nuclear energy technology. We're looking at this really from a compact modular design with 180 megawatt thermal that can be run then at an electric rating of anything from 20 megawatts on large ships, for example. You could run it for 30 plus years, or you can run it up to its full maximum potential, which is looking at around 70 to 72 megawatt electric on one of these. Of course, you can scale that up to several hundred megawatts if need be. The nice thing about the molten chloride fast reactor in terms of the fuel efficiency also means that waste management is really not the way that we think about waste management in nuclear today. We think that the spent fuels management for something like the molten chloride fast reactor is really a sales argument for the solution and not something that pulls away from it. We've got this potential also in this reactor, which is one of the reasons why the French are involved in this, that we can use spent nuclear fuel. So existing nuclear waste can be burnt up in a fast spectrum reactor, and particularly then in a fast spectrum molten salt reactor, we've got a very efficient way of gradually depleting that nuclear waste that sits stored around the world that people are concerned about. If we can turn that waste to energy system around, we've effectively got, I think, what will be a closing of that fuel cycle in nuclear, which is going to be a very positive thing. I mentioned earlier about nuclear propulsion. So if you take one of the largest container ships in the world, the one that was stuck in the Suez Canal that you will have seen, the Ever Given, she's a 20,000 TEU, a 10,000 40-foot container vessel that there's about over 400 meters long. We've done a concept study with one of the big Japanese shipyards recently where we demonstrated how one of these reactors will run that ship for a full 30 years on a single fuel load and leave 1.3 tons at 1,300 kilos of final residue waste, which is no larger than what I'm showing here, which is a dishwasher. Take that into account, from the shipping industry point of view, the industry is now tearing itself apart, trying to figure out how it's going to decarbonize, move away from the large diesel engine, which means that the industry has to move away from its current waste footprint, which is 1.1 billion tons of carbon emissions per year, of which about 10% is still with us after 120,000 years. So talking about long-term waste storage, here is an issue that we have already from fossil fuels. Here is a solution that can change that dramatically by having true zero emissions on these larger ships. We think that changes the value chain for industrial components, for durable consumer goods, and for consumers around the world. This thing with the emergency planning zone, I think, is terribly important because, the issue of having an emergency planning zone for large reactors, which can be up to 80 kilometers on the largest power stations. Maybe Clare can answer some questions later on about what the size is around Sizewell and the same thing for some of the smaller modular reactors. You're looking at a very large area around the reactor that has to be an emergency planning zone. You have to be prepared for what would happen in the event of an accident with the reactor, the formation of a plume from a pressurized system that would potentially spread radioisotopes into the environment. If you have a non-pressurized reactor, we're really looking at an emergency planning zone that could be it could be measured in meters. Ideally, what we're looking at.
I think you need to advance your slides again. Yeah.
Sorry, apologies. I'm using the wrong screen. Emergency planning zone of meters rather than kilometers, which means that we have a we have the potential to have that EPZ, if you like, on the actual vessel itself and not stretching outside, which means that you can move up and down rivers, you can have them near to the coast, you can have these sitting near coastal communities and small island states, etc. We think that matters a lot. And I think it matters a lot for Singapore as well. One of the key things about nuclear in Singapore is the idea that you have a small nation, very high population, of about 5.5 million people, and a large emergency planning zone of anything between 50 and 80 kilometers in Singapore covers a very large portion of the country. So here is a potential solution for countries like Singapore, where you need to be able to contain this in a very, very small area. That large container ship that I talked about earlier is the one that we did that design of in Japan, and is now in the process of getting moving from concept design to basic design. It does special things in the sense that we can get a very high speed on this vessel, which shortens trips around the world. She's true zero emissions, so she is effectively not emitting anything during her lifetime. Of course, there's a carbon footprint in the manufacturing of vessel and the reactors and the fuel and et cetera, but it is very, very small. The special thing about being able to do this is that you've effectively got a vessel that can go faster, carry more cargo, and do it for longer than ships today, and it's immune to carbon pricing. Every single ton of bunker fuel used on a vessel is about 3.2 tons of carbon dioxide. And we're now looking at a new carbon taxation regime being introduced into the shipping industry over the next few years of anything between $100 and $300 per ton of carbon. If we take a midpoint there at about $150, each one of these vessels would have a carbon taxation cost of $750 million over a lifetime of that ship. You can add that to the operational expense of the vessel, which gets passed on to the consumers, and that becomes expensive container shipping. So we believe that the way that these new types of reactors can make these ships more competitive is basically by having them completely immune to carbon taxation, being able to carry more cargo faster and for longer. It puts competitiveness back into this industry. Last thing I'd like to say about these ships is that we can also, whilst they're in port, provide power in those ports. So you can do what's called reverse cold ironing. You're effectively, diverting the electric power from the nuclear plant on board away from the propulsion system and onto the port. So you're now powering the gantry cranes and the loaders and dischargers that are functioning in that port and helping to decarbonize port communities around the world. That, we believe, is a very popular thing.
Next slide.
In terms of floating power, we've designed this this large floating power station that I showed you earlier on. It's effectively a 4-reactor system with molten salt reactors on board, providing anything up to 1.2 gigawatt electric. So you've now got basically floating power that you can plug hydrogen production plants, ammonia production plants, or plug it straight into the grid. The nice thing about, of course, this type of reactor technology as well is that you get high temperature heat as well as electricity. So you get that additional efficiency combination of high temperature heat and electricity to get more efficient hydrogen production, ammonia production, methanol production, synthetic fuels production as you go along. We've recently also released a report which is called The Future of Water, and we believe that floating, sort of advanced nuclear floating water desalination plants, again, constructed in shipyards, moved to where they're needed to be, can be the solution for a lot of small countries and areas where water stress is becoming a major issue. demand for what desalination is forecast to get to close to 300 million cubic meters per day by 2050 and continue on from there. And really, the only way that we're going to be able to keep up with this is to desalinate more water. And to do that without a carbon footprint, we are going to have to use nuclear technologies to do so. Constructing those in shipyards, putting them on flexible, movable systems that sit out at sea, surrounded by all of the water that it needs to desalinate, as well as the ultimate, if you like, heat sink and coolant that we need around these, is the ultimate way to do this. Nations like Tonga and Fiji and the Caribbean, etc., can look to this technology as being one that is immune to the kind of disastrous tsunamis and cyclones and hurricanes that eventually come through and devastate those countries. Electric power and desalinated water, a fantastic way forward for this. The way that Core Power gets involved in this is that, you know, we're partnering with large organizations to build reactor technology. We are specialists on the maritime side, not on the nuclear side, so that's why we partner with companies like TerraPower, Southern Company, and others. And our mission is really to build and fulfill these markets. So we co-fund the reactor development. We're investors in the Molten Chloride Fast Reactor and a couple of others. We contribute that marine engineering to those organizations so that they can make these reactors marine ready through, if you like, early designs, through demonstration and into the final production stage. We develop the entire power package around this. So that nuclear electric power package that's appropriate for marine environment is important to this. And of course, we are deeply involved in the work in modernizing regulations for this. No regulations currently exist that are valid really for floating nuclear power plants or transportable nuclear power plants. And we're deeply involved with the International Atomic Energy Agency and various regulators around the world to make sure that those rules and regulations are set out correctly. And of course, then we engage with industry. We're backed by shipping industry investors. You know, we have 42 shareholders in Core Power, all from the shipping industry. And that's, you know, there's more and more of those coming through. So maritime is getting behind this. And eventually, of course, our aim is to fulfill these markets and make sure that, you know, these solutions get put out and create solutions not just for countries, but for industry and heavy transport. At the end of the day, we've got a market here which is extremely high barriers to entry. It's fully unsaturated and it's imminently scalable. We think this is going to be a phenomenal way forward for new nuclear, and, you know, to go hand in hand with renewables and conventional nuclear. And with that, I'll finish my presentation and thank you very much for listening.
Thanks, Mikhail. And can I ask the panelists to turn their cameras on now, please? Thank you. And maybe we should start, as the panelists put on their on their cameras, with the point that you just started to talk about, Mikhail, which is, and the headline, I think, there are no regulations. Okay, and you know, from that point of view, to actually go about developing this business in terms of pace and scale, whether we're actually talking about SMRs and on-grid energy versus some of these more, you know, exotic types of development, there's a long way to go. So I guess I've got a question representing both the IMechE and the Energy Institute around, yes, it does look like nuclear is very much back on. Yes, there is an appetite to get things moving, but boy, you know, how quickly do we need to get governments and standards and everything up and running before we can truly develop markets and regulations and a true business around this? So a fundamental question, I think, really to Clare and Paul initially is, you know, having started this in the UK, is how do we go about accelerating the reality around regulatory development that is required around all of this stuff? Paul, maybe you'd like to kick off.
Right, okay, yeah, it's a great question. So hopefully I've tried to sort of outline from a RollsRoyce SMR perspective, we've deliberately tried to mitigate the risk of having problems going through the regulatory process by the kind of plant we've designed. So that's the way we're attempting to minimize the timescale. Essentially, that's what we're talking about here. So as I touched on, we've already started that that formal regulatory process. We're underway with that. We'll come out of that 2026. We're not expecting any curveballs, and that means we'll be good to go. In terms of how quickly can we start to make these things, yeah, if somebody wants to give us an order, we can start. We can start making product realistically sometime 2024. We'll have the design mature enough to start making the long lead items then, and that's certainly what we're driving to do. So hopefully that, yeah, gives a view from my perspective.
Claire, do you want to follow on?
Yeah, I think I would add to that one of the sort of key strengths of the nuclear industry, which has existed for decades, particularly within the UK, is that it has these really strong, stringent levels of regulation and safety in place. And so this is something that, as we look to develop new technologies and build out other forms of low carbon power linked to nuclear, we can build on. But certainly there's a really strong kind of baseline there that the existing industry can build on. With Sizewell as a next of a kind project to Hinkley Point C, one of the key savings of doing something again and replicating it is that for Hinkley Point C, the reactor design went through the UK process to receive approval. And so Sizewell C is starting from a point of already having this design approved within the UK. And so that's saving a significant amount of time and a significant amount of money by just being able to replicate and take this fleet approach. So certainly there's a balance between the benefits of doing something and replicating it, and then also bringing forward the new technologies that we need. When we talk about linking things like hydrogen or direct air capture and other technologies to nuclear in the future, then these are industries that are, the low carbon hydrogen industry, for example, is something that needs to develop and is a really key focus of the UK government. And so we're hoping that with the role of industry coming in to support initial innovation in the hydrogen economy and strong support from government, then that's something that can come together with those net zero targets to really drive this through within a timeline that will allow us to tackle climate change.
So just before we pass on to Mikal for some comment, another issue around this pace and scale is, of course, competition. And the fact that, it's not just the UK doing this. Other countries, you've got EDF, you've got GE, Hitachi, and, looking to the east, China, all looking at similar technological developments. But a lot of these technologies will only work once they're scaled up, and there's a really material market to develop around these sort of technologies. So again, on the one hand, everybody's looking at it, but how does one get to that point where one can start creating those material markets which are required in order to get the costs down and the technologies up in terms of full-scale development? Claire, Paul, just before I pass on to Mikal, because I think he will want to answer this from his perspective as well, but let me just pose that question to you first again quickly.
Yeah, of course. I mean, as we know, competition has a key role to play within any industry in driving out innovation and reducing costs to the consumers. But there is also within the nuclear industry a really strong culture of sharing lessons and speaking to each other across different projects around the world. And it's through this sort of wider nuclear industry collaboration that we're able to achieve the really sort of strong levels of safety, reduce costs, and do things better over time. So with each development, we're learning from what we've done in the past, and we're able to take those learnings and build things quicker and at a lower cost. And so that's one of the key ways that the nuclear industry can support the government in getting to net zero.
Thanks, Paul.
Yeah, I think that's correct. And I was thinking as Claire was talking earlier that the UK regulatory process is a gold standard of how to do things, and SMR are trying to apply the way the Office of Nuclear Regulation was set up in terms of going through generic design assessment. We're trying to actually use it probably in the right way for the first time, where we're bringing the regulator along with us. So that's certainly an aspect where we're trying to speed things up. I think in terms of the market's huge. RollsRoyce SMR alone can't feed that market. It's massive, and so competition's great. As you've mentioned, there's a number of players. arguably competitors, but they're not really competitive because the massive, in our opinion, the market is so massive that touching on Claire's point, we will work together with our, in quotes, competitors, because that's the way the nuclear industry operates, and that's how we'll carry on operating. I think it's a really important aspect.
Thanks, Paul. And now over to Mikal. I mean, obviously looking at it from a very different angle in terms of the maritime industry, clearly standards and making sure that there is some sort of common view as to how some of these newer technologies will emerge is going to be important. So over to you for some comment around this, Mikal.
Thanks, Peter. Look, I think there's three questions in there, isn't there? One is pace and scale. Do we have time to do all this stuff before it's too late? And I think the answer has to be, well, the most important thing is to do the right thing and to do it right, not to think so much about the time scale of it. Whether this is technology that is here within 5 years, 6 years, 10 years, or 20 years is not really the main point. This is technology that can take us hundreds of years into the future, and there's more to this, more to the future of the next generation than the next 10 years. So I don't think we should be too scared about the timing of things. I think on the regulatory side, which is the second question, when I said there's no regulation in place, of course there is regulation in place for this. It's just that there's no real specific up-to-date rules for how you do things with nuclear in the maritime space. For maritime propulsion, there are rules that were written back in the 70s and passed at the International Maritime Organization in 1981. And that is SOLAS Chapter 8, Safety of Life at Sea Convention, Chapter 8, which has the nuclear code for exactly how you construct, how you operate, and how you decommission nuclear vessels. It's out of date. It's old. It's not referencing the 40 years of advancement in nuclear safety and security at the International Atomic Energy Agency. It doesn't even take into account properly the advancement we have in maritime safety. So there is an enormous amount of effort being made to, if you like, find out exactly how we modernize those rules. And the UK, again, is taking the lead on this. So the UK Maritime Coast Guard Agency, part of the Department for Transport, is now passing that code into law this year, this autumn, in fact, and with a view to then bringing a modernization program to the International Maritime Organization together with friendly nations, partner nations like the United States and France, etc. So that's happening. On the floating nuclear power station side, it's not like we need a huge amount of international rules and regulations to do so, because countries can decide how they want to do it. Here in the UK, the ONR and the HSE can regulate, if you like, what happens in UK waters. Same thing happens in other countries. But at the IAEA, there are now committees having worked for a number of years in getting to the point where the documentation is now being produced as guidance for nations on how to deal with security, safeguarding, nuclear safety, of course, and sort of transportation of some of these systems. The last question that you asked is, how do we get scale in this? Well, I mean, I think I'm trying to answer that a little bit in my presentation when we're talking about, going from project to product. If we can create products, again, we have to think small here. We can't think big power stations because they're too big to be products, but we think small. We think about small modular reactors in different sizes, different shapes and different types of energy systems that are in them. We could potentially move to mass assembly. We can move to mass deployment, because you can do things in a certain place. I don't think Rolls-Royce is demonstrating this with their small modular reactor in the factory built one, but if you can do this in shipyard and you can put it on a maritime asset, you can move it anywhere in the world where it's allowed to be, where it's wanted, and where there's desire for this kind of power. That's how you get scale. I mean, we could do theoretically an unlimited amount of reactors and systems that are deployable at sea through the shipyard, specific shipyards that have to obviously gear up to do this in the West and the East and wherever it is. It doesn't really matter whether it's happens in Asia, Europe, America, and the Atlantic. This is the way it's going. And I think that's the way you get real scale in this.
Okay, so I would say yes, but okay, and it raises another question, or two questions. One of which one of our questioners, one of the audience has asked around obviously security, but let me also broaden that question out. The whole issue of advocacy and socialization of these new technologies into society, into the market, remains a significant barrier for the nuclear industry in general. So again, given the fact that regulations are beginning to develop, what needs to be developed around the advocacy socialization side to really begin to start bending the needle in favor of nuclear and the nuclear sector as a technology? Claire, would you like to kick off?
Yeah, so I think if we start with the UK, we probably have seen a really strong move in favour of nuclear, and it's now something that the government is firmly stood behind. There's a number of reasons for that. Recognition that nuclear is a proven, scalable technology that can produce vast amounts of low carbon power and support the sorts of targets that we have is a key one. More recently, because we're seeing this increased focus on energy security around the world, then it's increasingly something that countries are looking at how they can have that homegrown energy supply that supports renewables, other forms of technology, and helps to reduce reliance on Russian gas and energy sources. And so that is, it's not something that anyone could have predicted or anyone would have wished for, but it is something that has really changed the way that governments around the world are thinking about nuclear. A country such as Germany, which we know is a really good example of one, or perhaps not a good example, but it is an example of a country that has taken quite a hard stand against nuclear, is actually reconsidering the role of its existing nuclear fleets and its phase out plan. And that's the sort of most extreme example. So many other countries that were perhaps more just not considering this, but didn't have a strong sort of anti-nuclear stance, are also now thinking about the role that it can play in their energy mix in providing that secure, homegrown source of supply. So that's something that's a strong geopolitical driver. Something that we within the nuclear industry can do and look to do is just ensure that we're providing the information, the facts that people need about the way that the industry runs and the way that nuclear has contributed for decades to the world's energy, and the UK's energy supply are also kind of really key roles.
Thanks, Claire. Mikal.
I think, Peter, the misunderstanding about how people feel about nuclear around the world is one that's often propagated by certain types of media. We're finding that younger generations are massively in favor of nuclear, not just here in the UK and the US and across Europe, but also we find this in Singapore, and we find this in Japan, and we find this in Korea, and we find this all over the world. There is this strange illusion that somehow nuclear is unpopular because it's been painted as something dangerous. When people start to realize that nuclear weapons and nuclear energy are two entirely different things. It's different from a teaspoon and a cannon, if you like, both made of steel, but really not really the same thing. Then, we start to see this breaking apart. I think support for nuclear as an efficient, proven, safe, always on green technology that doesn't spoil the environment, that doesn't ruin nature, doesn't have hundreds of thousands of kilometers of ocean filled with carbon fiber blades or nature covered in solar panels. There's just as much opposition to that as you find to anything else. It becomes a real thing, right? I mean, we can't argue with physics, Peter. Physics is physics. It shows us the energy density we get from nuclear and the safety record of this industry, which is second to none. I mean, really is one that has been largely misunderstood. And I think young people are starting to understand that, and we see a shift towards supporting nuclear, not just from nations and governments. I think treating Germany like one thing is a mistake. It's really the green lobby that's done this, and there's a lot of Germans who are perfectly in favor of nuclear, would like to see this happen. I think young people all over the world agree this is the way forward.
Paul, particularly interested in your comments around security, because again, as these assets expand into different markets and, become effectively mass produced, the security issue is a real issue, and it needs to be dealt with, and it needs to be in some way managed going forwards, both on a national and potentially international and global scale. And certainly, as one of our questioners asked in the terms of shipping, if we do have nuclear vessels going around from country to country, it needs to be addressed at a global level in order to get the assurance that we need. So how do we deal with those issues quick time, given the fact that we obviously want to see the nuclear sector develop as quickly as possible?
Yeah, so I touched on some of the features we put into the power station that try and deal with that. We also have got a very safe plant, so probabilities are very, very low of severe accidents, well beyond where the industry has been in the past. And I think touching on what Clare and Mikhail have said quite rightly, the perceived risk of nuclear in the population is just totally disproportionate to what the real risk is, and we've not done a great job, and Claire touched on this right at the start. I think the nuclear industry have done a rubbish job of promoting itself, and we need to stand up and say that we are actually really, really good. You know, the deaths due to nuclear are phenomenally small compared with, you know, if you think right now the world produces what, $4 trillion US worth of coal, gas and oil. The resultant air pollution associated with that contributes to, well, whichever way you look at it, millions of deaths per year. Nothing like the nuclear. Absolutely, we're not in the same league, and yet people don't recognise that. They don't understand that, and we need to explain it, and you know, give people the data to work it through and touch on that. I mean, interesting. I saw one of the comments talking about boron chemistry, and that's an important aspect of the way we're trying in SMR to reduce that perceived risk. We're removing boron from our primary chemistry. That reduces tritiated water, means we've got zero discharges of tritiated water from our plant. That's a massive benefit to the environment, and starts to sell the message that nuclear is safe and it's getting safer. We're actually engineering safer solutions, and that's really important.
Okay, so moving that on, and you mentioned, Paul, in your presentation, you know, with regard to SMRs, the issue of off-grid versus on-grid. Now, obviously, these are two fundamentally different markets in terms of the way they're administered, the way they're managed. So to a certain extent, I can go along with security being sorted out on-grid, you know, with national utilities companies and infrastructure companies dealing with this. Off-grid, when we begin to start seeing these types of developments going into places, God knows where, you know, in terms of where they're at, how does that side of it get managed? Because again, those are really at the nascent stage of development when it comes to any sort of regulatory framework that has been developed in the past. So to me, there is a differentiation between standards around the bigger industry and standards around what might happen off-grid. Paul, would you like to comment on that?
Yeah, I mean, clearly the controls have got to be in place, and the security has got to be solid, and certainly within our plant, we've taken that on board and put a number of features into the design that tries to deal with that. Clearly, there's a resource burden associated with that, if that's the right word, that needs to be included into the reactor design. You don't sell or locate power stations in regions that are clearly a high risk, so that needs to be part of the whole discussion with who you sell product to. It's a challenge. I'm not saying I've got a simple answer to it, Peter, but I think it's something that can be worked through and managed and handled.
And looking at it from an Asian perspective or from a climatic perspective, a question is being asked around, obviously, you know, SMRs and how they work may vary somewhat, dependent on, you know, temperature, dependent on climate aspects, dependent on a number of issues related to the environment. Are those things that one needs to worry about, or are we able to see a cookie cutter approach to, if you like, the next generation of nuclear development?
In terms of our SMR, it's a global product. We don't perceive any. The only thing that I didn't really touch on, we've got a 50 hertz design. You know, there's a big market for 60 hertz, so we can develop our design to do that, and we're already starting to kick that off with Constellation. But no, it's a global product. given the restrictions we talked about already in terms of security and making sure we don't put them in places that are a challenge to look after, I don't think there's a great problem from an SMR a Rolls-Royce SMR perspective.
Very good. So we're nearing the end, so I'm going to ask my final question and come to the issue of money, okay, and investors. Sitting here in Singapore, obviously a financial center in this region. But, you know, and I'll start with Clare again, if I may. Why should investors be interested in investing in nuclear right now?
So investors are increasingly thinking about ESG, the environmental, social and governance impacts of their investment opportunities. And that's a big trend that we're seeing, both in terms of how they're being regulated and there's certain sort of requirements on them to report in line with this, but also just a shift globally towards recognizing that the long-term investments that take into account these factors are typically the ones that are performing better and are having a more positive impact on society. So the reason investors should be interested in nuclear is the same reason anyone else really should support nuclear. It's the role that it can play in reducing the carbon impact of our energy systems. It's the role that it can play in supporting renewables on the energy mix. And it's also because these are projects that have huge social impacts. So they create thousands of jobs and they create careers for people in the local areas that actually take them through the full cycle of a nuclear power plant and allow them to build these long-term sustainable careers. And this is something that, in the way that we talked about needing to sort of educate the public or the wider sort of perception of nuclear, it's, you know, investors are just the same. So nuclear isn't an asset class that they will be as familiar with compared to, for example, renewables. But it is one that we should seek to get them familiar with so that we can get this access to this private finance to support the industry and support the wider net zero ambitions that different countries have.
Thanks, Clare. And Mikal, I mean, obviously you're right at the center of this. You're an investor yourself. What's your pitch to investors that you want to bring on board right now in terms of saying, this is the right time to be getting involved in my business?
It's very simple, Peter. In terms of the maritime industry has for the last 30 years become extremely central to global trade, but it's losing its competitiveness. It's losing its technological edge, and it's gradually being suffocated by the need to move away from fossil fuels and the addition of carbon taxes. It needs a solution. It needs deep disruption. This is the most impactful disruptive technology that can completely change the competitive landscape in global trade. That is a good pitch, and we use it to great effect with a lot of investors. I think generally speaking, though, we have to look at a broader range of things here. And one of them is access for people to be able to invest in nuclear. I mean, you maybe Clare can answer to this, but you know, is there really a mechanism for people to put their money into something they believe in? If I wanted, as a private investor or as an institutional investor or as a corporate investor, wanted to invest in nuclear, you know, I know for a fact that I would struggle to find where I would put my money. I can buy shares in stock listed companies that are involved in nuclear, but how can I really do this? I know that Rolls-Royce SMR opening up for investors to come in. The RAB, the regulated asset-based program that's coming in the UK, is going to enable that. But it's very specific in localized areas. But if you're looking at global industries, you're looking at, you know, transportation, heavy industry around the world, you have to be able to provide that kind of, if you like, a commercial path to this happening. And I think, you know, organizations like us specializes in that. We've got, you know, the ability to put that money to work in disruptive technology, and that's quite unique.
Paul?
Yeah, so I touched on investability as part of the presentation, and it's got to work economically. So it's got to satisfy sort of the investment side of things, definitely. We do that in the way I've said. So you know, the scalability of it and having a standardized product, it gives confidence to the markets, and so that builds the investability. We're also working with the financial houses to work out, is there a better way of pulling together and pulling investors together to develop our SMR, but potentially other SMRs as well. I think if we took a government stance, say why should government invest? And Claire's already alluded to it. If we look at the figures for Rolls-Royce SMR, we're predicting potentially 40,000 jobs in the UK alone to do this. It's a massive job creation scheme, and that's why governments are interested, and that's why governments worldwide should be interested. Largely their job is to make sure that people get good employment, and certainly the nuclear industry is a fantastic career. I'm sure Claire would agree, and certainly I've spent many years. There's so many opportunities to have a great career, great tech. If you're an engineer, it's a superb place. So there's a whole range of reasons, both from satisfying sort of local economics, but equally the wider global economics of why this is important. And we need it, but for all the reasons we said, we've got an enormous global challenge and we need to fix this, and nuclear is definitely a way of tackling it.
Thanks for that. And just a final question on waste that has come in. Obviously, one of the final issues here is around waste, how the nuclear industry will handle waste. I think Mikhail touched on the fact that there's not much waste in some of his advanced technologies, but clearly the whole issue of the circular economy and the circularity of the nuclear industry is an issue, because every waste or amount of waste will be sort of negative in terms of the environmental footprint going forward. So views in terms of how that circular economy element will develop within the nuclear sector going forwards. Mikal, would you like to kick off?
I will. I'm very simply about this. I think if all energy industries are held to the same standard as nuclear is, then you'd have a much more level playing field on this. You'd have an area where you're looking at what happens to fossil fuels, what happens to renewables, what happens to all of the solar panels and batteries, etc., etc. If you take a full life cycle approach to how that's done, sort of well to wake, birth to earth, whatever we look at it, and then you put them alongside each other, you'll find that the nuclear industry actually is the only industry that manages its waste responsibly. And the fact that we can now take the next step forward from that and create, if you like, systems that start to use that nuclear waste. It's not really waste, Peter, it's unused fuel. The way that nuclear works today is equivalent to filling up your car with petrol, driving 2 kilometers, and then emptying the tank, and then filling it again, driving another 2 kilometers, and emptying the tank and storing that unused fuel somewhere. That reprocessing, that constant sort of recycling of that fuel, and using the final waste product, namely plutonium, into these new reactor systems that close the fuel cycle, is clearly the way forward. And then we have to ask, what happens to solar panels? What happens to the blades of wind towers? What happens to all of the smoke that goes in the air and the toxic sludge that comes from coal and gas and oil, methane slip, all these things? I think to single out the nuclear industry for waste is just one of those almost like conspiracy theories that's been propagated, and everyone's talking about it because they can't think of anything else to talk about. Look at it really, and you've got the answer staring in the face.
Thanks for that, Mikal. Any other comments, or Claire, anything you'd like to say, or shall we wind up there? We're slightly over time now.
Yeah, I mean, I agree with what Michael said, and waste is a really common question that we get. So when we speak to investors, there's quite a good understanding that nuclear is low carbon, it produces a vast amount of power on a relatively small footprint, and that's a really positive thing. But waste is perhaps one of the questions that these funds that are looking to invest for impact would still question, because of the environmental impact on that. But like we said, I would almost say the nuclear industry has a really positive story on waste, because we are an industry that know how to manage our waste and have done for decades, and it's something that's fully costed in and really considered before you're even able to go ahead with building a power plant. It is about just putting the facts out there again and allowing people to draw their own conclusions on it. But one quite nice fact, if you like, on waste is that the waste that is the waste that people are talking about, that more radioactive waste and the spent fuel, it's actually a relatively small proportion. And so if you take an American citizen, so somebody who probably has a more energy intensive lifestyle than others around the world, the amount of waste that would be produced by nuclear power, if nuclear power was used to power everything that they do throughout their entire lifetime, would fit back into a Coke can at the end. So that just gives an idea for scale, on top of the fact that, you know, we're an industry that know what we're doing with the waste and have managed it safely for decades.
Thank you for that. And Claire, Paul, Mikal, we've come to the end, I'm afraid. We're overdue for completing. Thank you all for your wonderful comments and the conversation that followed. We've covered a lot of ground today. Clearly, there's a lot of complexity around all of these issues, pace of scale. You know, we didn't really go into the design or the technical side of the nuclear SMRs in any great detail. So I think there's plenty of scope for follow-on opportunities for discussion in the months to come, given the interest. But you fund managers out there in Singapore, make sure you start thinking about putting a nuclear fund together. I think now is the time to do it. The timing is right. Listen to Mikal. I'm sure he's got it firmly in place. Thank you all very much, and good evening, good morning, wherever you are. We'll see you again.